Here's a number that should bother anyone building agents right now. Every time your retrieval system pulls the wrong document, your agent doesn't just get a bad answer, it requeries. It burns another reasoning turn. It carries the noise from that bad chunk to everything downstream. Retrieval isn't the boring part of your RAG stack. It's the part that decides whether the rest of the pipeline is even worth running. NVIDIA just released something aimed squarely at that problem. Open weights, and it's currently sitting at number 1 on the toughest retrieval benchmark that exists. Welcome to the Private AI Lab, the podcast where we experiment, explore, and debate the future of AI behind the firewall. I'm your host, Johan. No guest today, just me, a fresh NVIDIA release, and my honest read on what it means if you're running retrieval in production. Let's get into it. NVIDIA released Nemotron 3 Embed. Not just the one model, a family of 3, and the split matters more than the name suggests. Here's the flagship, Nemotron 3 Embed 8B BF16. That's the quality anchor, the one you reach for when precision, critical retrieval, and enterprise RAG are the job and you're willing to pay for the best answer. Then there are two 1B variants sitting underneath it. Nemotron 3 Embed 1B BF16 is the cost and latency sensitive option built for when you're serving retrieval at scale and every millisecond and every dollar per query counts. And Nemotron 3 Embed 1B NVFP4 is the same idea, but turned specifically for NVIDIA's Blackwell architecture using 4-bit quantization to squeeze out more throughput per GPU. That's the whole pitch in one sentence. Pick your point on the accuracy to efficiency curve, and NVIDIA has a model sitting on it. Not one model that does everything reasonably well, 3 models, each built for a specific deployment reality. And all of it is open. Open weights, datasets, training, recipes. You can inspect what these models were trained on, fine-tune them on your own data, and run them on your own infrastructure. And I'll come back to it. So let's run through some numbers and whether to believe them or not. Every model release comes with a single benchmark slide. I've learned to be skeptical on those by default, so let's actually look at this one. So Nemotron 3 Embed 8B BF16 ranks numbers. 1 overall on the RTEB, so the Retrieval Embedding Benchmark. That's not a niche internal NVIDIA benchmark invented for occasion. RTEB tests retrieval across legal, financial, code, and healthcare domains in multiple languages, specifically designed to mirror real production retrieval demands rather than academic leaderboard games. The score is 78.46% on RTEB and 75% on MMTEB retrieval. Looking at the actual leaderboard, the 8B model sits ahead of the Voyage 4 Large from Voyage AI and Octane Embedding 8B, which is worth noting because Octane Embedding 8B is roughly the same parameter count. Same weight class, different result. Now, the part that actually matters if you're not running the flagship. The 1B BF16 model scores 72.4 on RTEB. That's 27% reduction in error rate, compared to its own predecessor, Llama Nemotron Embed VL1B V2. Same story on MMTEB retrieval, a 28% error rate reduction. That's not a marginal bump, that's a kind of generation jump that changes which model you'd actually deploy. And here's my honest assessment, because I don't take vendor benchmark slides at face value. This is a real result, not a cherry-picked one. RTEB is specifically built to resist the kind of benchmark gaming that's plagued embedding leaderboards for years. When a model tops at that particular list, I pay attention. So this is the part of the release I think most people will skim past, and it's probably the most important one for anyone building agentic systems right now. NVIDIA ran an evaluation where they kept a search agent powered by Nemotron 3 ultra constant and only changed embedding model behind it. Then they measured downstream agentic token cost per query across Vidori, V3, Bright, and BrowseCom Plus. The finding, better retrieval, doesn't just mean a better top result. It means the agent stops requerying. It stops burning reasoning turns chasing evidence the retriever should have surfaced the first time. So Nemotron 3 Embed 8B BF16 delivered both the highest retrieval accuracy and the lowest estimated downstream token cost across all three benchmarks. I've said this before on the show, the infrastructure question always gets skipped in the excitement about what the agent can do. Nobody talks about the retrieval layer until it's a reason your agent's costs are 3 times higher than they should be. So this is the first time I've seen a vendor actually quantify that connection instead of just asserting it. So how did they actually build this thing? Let me get into the technical part, because the build process here is more interesting than, the typical we trained it on more data story. The 8B model starts from the Ministrel 3 8B Instruct 2512 backbone. NVIDIA took that casual decoder, the kind of model built to predict the next token, and converted it into a bidirectional encoder built for full sequence retrieval. Then contrastive pre-training on web-sourced and synthetic text pairs, followed by fine-tuning on curated multilingual retrieval data across legal, finance, medical, business, and education domains. The 1B models are where it gets genuinely clever. This isn't a small retriever trained from scratch. NVIDIA started with the Ministrel 3 3B backbone, applied that same bidirectional adaptation to get the 3B retriever, and then ran it through 2 rounds of structure pruning and distillation. First round, compressed the 3B down to a 2B intermediate model using NVIDIA's ModelOpt neural architecture search. Then distill that from an 8B teacher checkpoint to recover ranking accuracy. Second round, repeat the exact same process, prune and distill again to lend it to the final 1.14 billion parameter model. Training used a 2-stage context schedule too. Stage 1 at 1024 tokens to rebuild the coder retrieval behavior. Stage 2 to expand it to 4096 tokens with long context and reasoning data added. So the 1B model doesn't fall apart on longer inputs the way the small models often do. The result is a 1B model that's the far end of a distillation chain starting at 8B, not a lightweight model that was designed small from day one. That's why the accuracy retention is as good as it is. So let's look at the Blackwell angle based on FB4. Now, the piece built specifically for scale, the Nemotron 3 Embed 1B FB4. This variant quantizes weights and activations in the linear layers down to NVFB4, a 4-bit format native to Blackwell, and uses what NVIDIA calls quantization-aware distillation to basically recover accuracy that would normally be lost on longer input sequences. The result? Up to 2 times higher throughput than BF16 on the Blackwell hardware, while retaining 99% plus of the BF16 model's retrieval accuracy. If you're running retrieval at genuinely massive scale, doubling your throughput on the same GPU for a rounding error's worth of accuracy loss is the kind of trade-off you take every time. This is where the open by default part of this release actually turns into a real cost conversation for infrastructure teams, not just a nice to have for researchers. So, who's already putting this to work? A model release means very little until people outside the vendor start using it. So I want to run through who's already evaluating Nemotron 3 Embed, because the list tells you where this actually matters. Boomi is looking at it for agentic retrieval, and their senior vice president of product management specifically called out the flexibility of having both a 1B and an 8B variants to balance quality, latency, and the deployment requirements. IBM has early results from a proof of concept on watsonx data, and Palantir is collaborating with NVIDIA on edge retrieval workloads for AIP customers. ServiceNow is testing it against their own documentation, with an eye on fine-tuning it further. Turbopuffer is bringing it into their native embedding service, and Zoom is evaluating it for its retrieval layer behind their enterprise agentic search, pulling context across meetings, docs, chats, and tickets. But the one that stood out to me is Zep. They're actually an agent memory company, and agent memory is exactly the kind of workload where retrieval quality compounds over time. Every wrong memory retrieved poisons the next reasoning step. So Zep benchmarked Nemotron 3 Embed 1B against several models they already use, including some considerably larger, and it ranked first across every memory retrieval task they tested. Mem0, another memory provider, is running a similar evaluation right now. That's not a coincidence. Agent memory and agentic retrieval are exactly the workload this model family was built and evaluated for. When two companies in that specific space independently start testing within days of a release, that tells you that NVIDIA built this for a real gap, not just a leaderboard. Let's look at the open part and why it matters to me specifically. I want to close on the thing that actually gets me interested in a release like this beyond the benchmark numbers. Open weights, open data sets, open training recipes, including NVIDIA NeMo auto model recipes for fine-tuning and distillation. On NVIDIA's own NVDocs evaluation, fine-tuning the 1B BF16 model on their internal documentation moved NDCG at 10 from 56.7% to 63.3%, and the recall at 5 from 56.1 to 62.8%. Double-digit improvement from fine-tuning a model that already ranks well out of the box. That's the part that turns this from a good benchmark result into something I'd actually put on my own infrastructure. I run my home lab specifically because I want to know what a model does with my data on my hardware, not on the vendor's demo environment. A retrieval model with open recipes for domain adaptation is one I can actually test that way, rather than take it on faith. And it ships day 0 on Hugging Face and as an NVIDIA NIM microservice with VLLM support, and through inference partners like Base 10, Deep Infra, and Open Router. No waiting for access. So here's the recap. Nemotron 3 Embed, 3 models across the accuracy efficiency curve. The 8B flagship ranks number 1 on RTEB at 78.46%, with the highest retrieval accuracy and the lowest downstream agentic token cost of anything NVIDIA tested. The 1B BF16 cuts error rate by roughly a quarter over its predecessor. The 1B NVFP4 doubles throughput on Blackwell while keeping 99% plus of the accuracy. Open weights, open data sets, open recipes, 32K context, and enterprise teams already running it in production evaluations within days. The thing most people will skip past in this announcement is that retrieval quality isn't a search metric anymore. It's a cost line item in every agent you deploy. This release is NVIDIA making the case that the retrieval layer deserves the same attention as the model doing reasoning. I think they're right. So one more thing before I let you go. This is the last episode before I take a summer break. I'll be back at the end of August with more Nemotron updates, more experiments, more behind the firewall, and more interesting guests in the lab. So enjoy the rest of your summer, and I'll see you then. Thanks for tuning into the Private AI Lab. Don't forget to subscribe on Spotify, Apple Podcasts, or YouTube, or the Private AI Lab newsletter on LinkedIn. and visit johan.ml for more insights and experiments. Experiment complete. Until the next one, stay curious.
Private AI Lab.